So now, instead of just hiring for one job, you're hiring for multiple jobs. And so in your new store, you need 3 cashier, 4 clerks. There are 7 applications for the cashier and 8 applications for the clerk. How are we going to do this? Well, the question that comes up in this one, does it make sense that for the cashiers, there's 7 applicants and we need to choose 3 of them. The order would not matter. And for the clerks, there's 8 applications and we need to choose 4 of them, and the order doesn't matter. What are we going to do with these 2 numbers? 7 choose 3 is one number, 8 choose 4 is another number, and you have a decision to make. Are we going to take this and add these 2 answers together? Is this a cases question? Or are we going to take these things and multiply them together because this is a spaces question? Well, the way to think about it is, what are you doing? Whenever you're doing a cases question, you've counted something in its entirety. What do we want to count here? We want to count how many ways 7 employees can be chosen. Once I've done the cashiers, have I chosen 7 employees? No, I've only chosen 3. And when I've done the clerks, I've only chosen 4. So each of those aren't a full case. They're not counting something in its entirety, but just missing some other ideas. It's only a part of the entire thing. What we're doing right here is actually a decisions question. You have, as the owner of this new store, you have 2 main decisions you have to make. You have to hire cashiers as your first main decision, and then you have to hire your clerks as your second main decision. Within that, how many choices of cashiers do you have? Well, every group of 3 from 7, and then this will be multiplied by 8 choose 4. So we put this entire thing into our calculator and we figure out how many there's going to be. (12, 13, 14, 15, and 16. We are going to do part of 15 together. 15A, we're going to do 15A algebraically to practice it. So now it's a solve equation with combinations. So using your combinations formula, NC2 means there would be n factorial on top, 2 factorial on the bottom. What would be here factorial? It would have to be n minus 2 because the bottom 2 have to add up to n. And this is equal to 28. So how do we solve these equations? Well, this is very similar to our permutations one. When you're dealing with factorials, we expand the bigger one. Which is bigger? N. We could also, if we multiply both sides by 2, can you see that those 2's would cancel out and we'll get equal to 56 on this side. Expanding the bigger one, n is bigger, 1 less is n minus 1. We keep going until we hit n minus 2. And then those cancel out. And what kind of equation are we left with? Quadratic. So we solve a quadratic equation by making one side equal to 0. So I'll move the 56 over, factor that. So n minus 8, n plus 7. And we get 2 answers. N could be 8 or n could be negative 7. But we have to go back to our original question and say, do these both make sense? Well, our original question was n choose 2, n items, choose 2 of them is 28. 8 items, you could choose 2 of them. So this makes sense. You can't have negative 7 items and choose 2 of them. Right? So let's put word problem. You've got negative 7 friends and you want to invite 2 of them to your birthday party. How many ways can you do that? Well, that's very confusing and doesn't make very much sense. Then there just is no solution. So you could have something that doesn't make sense, like n choose 3 equals negative 8. Well, you can't choose something and get negative 8 options. So that would be an example of something that doesn't work. Sometimes you'll get equations where if you solve them, then n is a decimal. Well, you can't have 4.5 objects and choose 3 of them.